Now we'll talk about reaction of organic halides, right, HaloAlkanes and HaloArenes with metals, right. These are some important reactions, right, and many organic halides like organic chlorides, organic bromides, organic iodides, all these react with metals, right, to form compounds that contain a metal and a carbon bond, that is a bond between metal and carbon atom, right. These are new type of compounds, right, that would be listening for the first time, I think, now. So for example, if this is your CH3Cl, right, this is your organic halide methyl chloride, it will react with magnesium metal, right, to form a compound that contains a metal and a carbon bond, right, carbon and a metal bond, sorry, right. So such compounds that contain carbon and a metal bond are called as organometallic compounds, right, and these are very important compounds, and you will have these compounds in detail, right, if you keep studying chemistry in your graduation, post graduation, you will always have organometallic compounds, right. So it's important to understand here the basic of what organometallic compound is, right. So when an organic halide, right, like here methyl chloride, or if you look at this reaction, this is your bromobenzene, right, when it reacts with metal, any metal, here I have taken magnesium, it will form a compound, right, where you have compound that contains a carbon and a metal bond, right. Such compounds are called organometallic compounds, right. And there is a class of compound in organometallic compounds, right, which is formed when I take magnesium as a metal. When we take magnesium as a metal, the organometallic compounds are termed as Grignard reagents. These are Grignard reagents, and these reagents are named in honor of scientist Grignard, Victor Grignard, because he was the one who discovered these Grignard reagents, right. So if you see a bond between carbon and magnesium, these class of compounds are called as Grignard reagents, right. So now let's talk a little about compounds that contain your carbon metal bond, right. You can see, let's look at this molecule, right. We know that carbon and metal say magnesium, has high electronegativity difference, right. Electronegativity of carbon is 2.5 and that of magnesium is 1.5, right, or I think it's 1.2. You can see there is an electronegativity difference between carbon and magnesium, right, and this difference is huge. Carbon, the electronegativity of carbon is 2.5 and that of magnesium is 1.2, right. So there is a huge electronegativity difference between the two. This is almost half of this, right. So we know that when electronegativity difference exists between two atoms in a bond, right, the bond will become polar, right. Now if this is your bond, now the more electronegative atom will pull this electron pair towards itself, thereby generating polarities, right. Here carbon has high electronegativity, so carbon will pull, or this shared pair of electron will move towards carbon, right. So this would be positive, this will become negative and this will become positive. So we say that this bond, right, in organometallic compounds carbon metal bond is a polar bond, right? So this is your bond between carbon and magnesium is polar covalent bond, and bond between magnesium and this halide, this halide may be chloride, bromide, iodide, this bond is your ionic bond. This bond is your ionic bond, and this bond is your polar covalent bond. Right, just understand the chemistry of organometallic compounds, right? This is basic. Since I said that carbon is negatively charged, because of high electronegativity, carbon has acquired a negative charge onto it, right? So if this bond breaks, right, what will form is this part that has a negative carbon, right? So we know that intermediates that have negative carbon are carbon ions, right? So these organometallic compounds, right, are source of carbon ions, right? So in chemical reactions, this negative carbon atom, right, due to which a carbon ion will get formed, would be attacked by electrophiles like, right? So these are source of carbon ions and would be attacked by electrophiles, would be attacked by electrophiles that are proton source reagents, right? That is the reagents that can give you proton, right? This is important reaction. So now suppose if this is your carbon ion, now if this would be attacked by a proton, what it will form is, it will form an alkane, or it will form a hydrocarbon, right? So it should be away from a proton source. Proton source can be water, right? It should not come in contact with water, or alcohol, 1 and 2 degree amines, right? Amines are also source of protons, or terminal alkynes, right? So whichever source can give it a proton, can furnish a proton, right, should not come in touch with organometallic compounds, because we know that as per this explanation, organometallic compounds are source of carbon ions, right? And carbon ions can easily be attacked by electrophiles, in this case proton, right? So when you prepare, due to this reason, since it can be attacked by a proton, right, it can be attacked by a proton, and this proton can come from water, because we know that water ionizes to give you proton and hydroxyl ions, right? So this proton can be made available from water. So water is a source of proton, right? So when you prepare organometallic reagents should be prepared strictly under anhydrous conditions. There should be no traces of water, right? Because if you have traces of water, this organometallic compound, right, would easily decompose forming your hydrocarbons, right? Because as per this reaction, I said that organometallic compounds is a source of carbon ions, which when attacked by a proton will form alkanes, right? So that is why whenever organometallic compounds are prepared, they are prepared under anhydrous conditions. That means there should not be any traces of water, right? There should be no water, right? Because if water would be present, it will furnish hydrogen ions, right? Hydrogen ions is an electrophile, will attack organometallic reagents, the carbon ions, forming hydrocarbons, right, resulting into decomposition of organometallic compounds, right? So this is important. Organometallic compounds should be prepared under strict anhydrous, under, let's say, anhydrous conditions. Anhydrous means no water, anhydrous conditions, that is no water, right? I hope this is clear. So the reaction of HaloAlkanes and HaloArenes with metal is important, right? And they will form organometallic compounds, the compounds that contain carbon and metal bond, right? Which is a polar covalent bond, and bond between magnesium and your halide is ionic bond, right? And these are source of carbon ions which will easily be attacked by a proton to form hydrocarbons. So they should not be prepared under hydrous conditions, or there should not be any traces of water, because water will give you hydrogen ions. Hydrogen ions will attack carbon ion to form hydrocarbons. So in presence of water, organometallic compounds gonna decompose into your hydrocarbons, right? So here are some important reactions, right? You can see this methyl iodide react with magnesium in presence of dry ether, right? No water, to form methyl magnesium iodide, which is a organometallic compound, a Grignard reagent, right? When you have a carbon magnesium bond, or when the metal is magnesium, what the organometallic compound would be called as Grignard reagents, right? And Grignard reagents have a very high synthetic values, right? When we say high synthetic value, they have a high synthetic value. When we say high synthetic value, it means they can be used in organic synthesis, right? They are used in organic synthesis. When we say organic synthesis, we mean when in the lab we synthesize different classes of organic compounds like aldehydes, ketones, carboxylic acids, right? So any class of organic compounds can be easily prepared from Grignard reagents, right? When we study different chapters, we'll see that we are using Grignard reagents to form different compounds. So Grignard reagents have high synthetic value because they can be used to prepare different organic compounds like aldehydes, ketones and all, right? Carboxylic acids. So this is one reaction where bromobenzene reacts with magnesium to form methyl magnesium, to form phenyl magnesium bromide, which is an organometallic compound, right? But chlorobenzene, just notice the two reactions. This takes place in presence of dry ether, but if you try to react chlorobenzene with magnesium, it will form benzene magnesium chloride in the presence of tetrahydrofuran, right? Now there is another important type of reactions, right, which is Wurtz reaction. In Wurtz reaction, alkyl halide will react with sodium metal, right, where these two R groups, right, will join to form this alkane, right? These are symmetrical alkanes. So Wurtz reaction is used to prepare symmetrical alkanes, right? So the other reaction, if you in place of Rx you take if the alkyl halide used is a is chlorobenzene basically, then the chlorobenzene will react with sodium metal to form this diaryl compound, right? This diaryl compound. The reaction is called as Fittig reaction, right? And if I do the same kind of reaction, that is reaction between haloalkane and reaction between a haloalkane, which one is a HaloArene and the other is a HaloAlkane, right, with the sodium metal, right, it will form this compound, toluene, right? And this reaction is when you use a HaloArene, right, and a haloalkane, the reaction with sodium metal, the reaction is called as Wurtz-Fittig reaction. Just remember the difference. When you are using only alkyl haloalkane, the reaction is Wurtz reaction. When you are using only HaloArene, the reaction is a Fittig reaction. When you are using haloalkane and HaloArene, right, haloalkane and haloarene, the reaction is a Wurtz-Fittig reaction, right? I hope this is clear. Now this is an important reaction, right? When you use iodobenzene, when you heat iodobenzene with copper, what you will get is a diaryl, right? This diphenyl compound, right? We call this reaction is named as Ulmann reaction. This is an Ulmann reaction, right? When we heat iodobenzene with copper powder in a sealed tube, we get this diphenyl compound, right? This reaction is called as Ulmann reaction. Now there are some active metals, that some active metals also react with your methyl magnesium bromide, like this ethyl bromide, alkyl halides generally, right? Active metals like lithium, zinc, right, lead, all these react with your alkyl halides to give you important organometallic compounds. Like lithium will react to form this compound, right? Then you have this ethyl bromide that will react with zinc in inert atmosphere. It will form diethyl zinc, right? And if you look at the other reaction where it will form a tetraethyl lead, this ethyl bromide will react with this alloy. This is an alloy of lead and sodium in presence of dry ether to form tetraethyl lead. Tetraethyl lead has an important use. It is used as an anti-knocking agent. Anti-knocking agent in gasoline, right? This is used as an anti-knocking agent in gasoline, which is used as a fuel in engines, right? I hope this is clear, right? Just remember that the tetraethyl lead is used as an anti-knocking agent in gasoline, and gasoline used as a fuel in automobile engines. I hope this is clear. So we learned here two important class of reactions, right? First type of reaction where organic halides, HaloArenes and HaloAlkanes reacts with magnesium or reacts with any metal, right, to form organometallic compounds that contains a carbon and a metal bond. If the metal is magnesium, what gets formed is Grignard reagents, right? Grignard reagents have high synthetic value, right, because they can be used to prepare any class of organic compounds like aldehydes, ketones, carboxylic acids, right? And we learnt about this organometallic compounds that contains a polar covalent bond due to electronegativity difference between carbon and metal, and an ionic bond, right, between metal and halide ion, right? And these are important source of carbon ions and would be attacked by electrophiles. That is why they are prepared under anhydrous conditions, because water can give you an electrophile, which is a proton that can attack this carbon ion to form hydrocarbon, right? And these are important name reaction: Wurtz reaction, Fittig reaction, and Wurtz-Fittig reaction. And these are some important reactions where your alkyl halides react with active metals to form these important organometallic compounds, right? I hope this is clear. Thanks.